Hello everyone. So this is session number 5, advances in food analysis, and the topic which we'll be covering today is scanning electron microscopy. So the topic which we'll be covering today is scanning electron microscopy, which is a continuation of the second, third and fourth topic. So what is the basic principle of a scanning electron microscope? The basic principle is that a beam of electrons is generated by a suitable source, typically a tungsten filament or a field emission gun. The electron beam is accelerated through high voltage and pass through a system of apertures and electromagnetic lenses to produce a thin beam of electrons. Then the beam scans the surface of the specimen. The electrons are emitted from the specimen by the action of the scanning beam and collected by a suitably positioned detector. The construction of the scanning electron microscopes, there are the basic components which are as follows: the electron gun, the condenser lenses, the objective aperture, the scan coils, the chamber, the detector, and computer hardware and software. This is how the scanning electron microscope looks, and these are the different parts which are labeled into the diagram. That is the electron gun, the condenser lens, the aperture, the scan coils and objective lens, and the detector. The electron guns are typically one of two types, that is the thermionic guns and the field emission guns. The thermionic guns, which are the most common type, apply thermal energy to the filament to coax electrons away from the guns and toward the specimen under examination, usually made of tungsten, which has a high melting point. The electron gun, that is field emission guns, create a strong electrical field to pull electrons away from the atoms they are associated with. The electron guns are located either at the very top or the very bottom of the SEM and fire a beam of electrons at the object under examination. These, however, don't naturally go where they need to. However, which gets us to the next component of the SEMS. So this is how the electrons pass through the filament, and the filament current is generated. The condenser lens. Just like optical microscopes, SEMS use condenser lens to produce clear and detailed images. The condenser lens in these devices, however, work differently. For one thing, they are made of glass. Instead, the condenser lenses are made of magnet capable of bending the path of electrons. By doing so, the condenser lenses focus and control the electron's beam, ensuring that the electrons end up precisely where they need to go. The objective aperture arm fits above the objective lens in the SEM. It is a metal rod that holds a thin plate of metal containing 4 holes. Over this fits a much thinner rectangle of metal with holes of different sizes. By moving the arm in and out, different sized holes can be put into the beam path. An aperture holder. This arm holds a thin metal strip with different sized holes that lines up with the larger holes. The metal strip is called the aperture strip. The aperture stops electrons that are off axis and off energy from progressing down the column. It can also narrow the beam below the aperture depending on the size of the hole selected. So this is how the objective aperture looks like. That's all for this session. Thank you.